Hey y'all, in this video, we're going to break down how Python actually runs your code. Alright, so CPython is the interpreter that reads and executes Python programs. Its core is written in C, and that's where the C in CPython comes from. The core of CPython consists of 12 major components, divided into two categories: compilation phase components, which run step by step before execution, and runtime components, which operate dynamically during program execution. The source decoding system reads raw bytes from a .py file, detects the encoding, handles byte order marks, and decodes the file into Unicode text. It will throw a syntax error if decoding fails. The tokenizer processes the Unicode text and produces a stream of tokens like name, number, op, encoding, indent, and dedent. This is the first step in the parser pipeline. The parser uses a parsing expression grammar to build a concrete syntax tree from the token stream. It's responsible for validating syntax. The AST generator converts the concrete syntax tree into an abstract syntax tree, representing the logical structure of the program stripped of surface-level syntax. The semantic analyzer and symbol table builder walks the abstract syntax tree to analyze scope and variable usage. It builds symbol tables for functions, classes, and modules, resolving variable lifetimes and visibility. The compiler transforms the abstract syntax tree into bytecode instructions and wraps them in a pycode object. It performs basic optimizations during this transformation. The virtual machine executes the bytecode instruction by instruction using a stack-based evaluation loop. This is the runtime engine that drives program execution. The memory manager handles dynamic memory allocation and garbage collection using reference counting and a cyclic garbage collector to manage object lifetimes. The built-in object model defines the internal structure and behavior of Python types like int, list, string, and more. Every object is a Py object, and every type is a PyType object. The exception handling system manages try-except blocks, propagates exceptions, and builds traceback objects when errors occur during execution. The import system handles loading and initializing Python modules, whether source, bytecode, or native extensions. It supports meta pathfinders and import hooks. The C API and extension interface exposes CPython's internals to C modules and embedding systems, allowing external code to create, manipulate, and run Python objects. All of the components I have mentioned plays a distinct role in how CPython works. At the start of execution, CPython runs your code through these components one after the other like a pipeline. The raw file is decoded, tokenized, parsed, transformed into an abstract syntax tree, compiled into bytecode, and finally executed by the virtual machine. But once your program is running inside the virtual machine, these components don't just take turns, they interoperate constantly. The virtual machine executes bytecode that references objects managed by the object model, allocates memory through the memory manager, raises and handles exceptions, imports new modules as needed, and can even call C extensions via the C API. So think of Python in two modes: compilation mode, a step-by-step pipeline, and execution mode, a live system where all parts work together dynamically. CPython is also the reference implementation of Python. That means it's the official gold standard version of Python that all other Python interpreters are measured against, like PyPy, which uses just-in-time compilation, or Jython, which compiles to Java bytecode. When we talk about Python in the real world, we're almost always talking about CPython, unless you're doing something highly specialized. Alright y'all, this is the end of the video. This is just an overview of the components that make up CPython, and in the upcoming videos we're going to go deeper into each component, explaining how they operate to execute your Python programs.